This is Mr. Waters, and I'm going to be doing some examples for page 642 in the homework of how to graph ellipses and how to find equations for ellipses. In each case, you'll be given certain information about the ellipse, and you'll use that to make the graph and to write the equation. So let's say we've got this information here. We have got an ellipse with a center at 0, 0, in other words at the origin. The focus, F for focus, or one of the focus points, is -1, 2, because remember an ellipse has two of them, so that's one of the two. And then the vertex is going to be at 3, 0, one of the vertices. Now remember, what the vertex is this. The vertices are the points where the ellipse intersects the x and y axis. They will be the major and minor axis points. So in other words, if I make a little sketch up here, a quick little sketch, here's an ellipse centered at the origin, more or less. Okay, those points right there, those are the vertices for the major axis. These are the vertices for the minor axis. So we've been given one of those. Now, you can see that because of how the information is organized here, we've got one focal point here at -1, 0, and we've got one focus out, or one vertex out here at 3, 0. So there's our focus point that we're given, and here's our vertex point that we're given. Well, you can see that because of how that information is organized, this is a horizontally arranged or horizontally oriented ellipse. That means this formula for it will apply. X squared over a squared plus y squared over b squared is equal to 1. That's the formula for a horizontal ellipse whose center point, right there, whose center point is at the origin. Well, in order to get the equation, we'll do that first. We have to figure out what A and B are. Well, A, of course, is the major axis distance. That's in red. That's this distance here from the center out to the major axis there. And then the B, remember, is the minor axis distance, the center from the center up to the minor axis point. Okay, so we have to calculate what those are and put those into the formula. Well, maybe you can see that since the vertex is at 3, 0, the horizontal vertex A is going to be equal to 3, because that's the distance from the center out to the major axis. Okay, also the focal point is at -1, 0. That means, okay, that's there. So that means that the focal distance, the distance from the center to the focal point, is 1. So that's going to give us that C is equal to 1. Now it goes, I suppose we might as well, since we're going to be graphing this, let's go ahead and now make our formal graph down here. Okay, put this all down. Okay, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. Okay, good. So that's going to that's our little graph there. So the major vertex is out there. The focal point is there. Okay, now, so we're going to put 3. Now, in order to calculate the B, we're going to use our handy-dandy formula. C squared is equal to A squared minus B squared. So 1 squared will be equal to 3 squared minus B squared. Okay, solving for B, we get B squared is equal to 9 minus 1, or B squared is equal to 8. Now we can immediately put those into the formula. Okay, if A is equal to 3, then A squared is equal to 9. So that's going to give us down here x squared over 9 plus y squared over 8. 8 is b squared. And in the horizontal ellipse, the a number, the biggest number, the major axis number goes over the x squared, or under the x squared. Now that's equal to 1. So there's our equation. Now to finish up our graph, we can see that if one vertex, one major axis is here at 3, the other one has to be here at -3. We can see that if b squared is equal to 8, then b, the minor axis distance, is equal to the square root of 8, which is equal to 2 rad 2, but it's also, for graphing purposes, about equal to about 2.8. So I go up to about 2.8 in the positive direction and in the negative direction. Okay, those are our major axis points. Now I'm going to use another color here. Now, just like we did when we were graphing circles, we sketch as neatly as we can our ellipse into that spot. So there we go. There is, more or less neatly, the equation or the graph of the ellipse, and here is the equation. Thank you.